Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the Business Logic Vulnerabilities module titled High-Level Logic Vulnerability. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy and then select all labs. And then do a search on business, logic vulnerabilities, and select lab number 2 titled High Level Logic Vulnerability. All right, let's get started. This lab doesn't adequately validate user input. You can exploit a logic flaw in its purchasing workflow to buy items for an unintended price. To solve the lab, buy a lightweight leather jacket. You can log into your own account using the following credentials. Alright, so the target goal over here is to exploit a business logic flaw in order to buy this specific item for a price that is not listed in the application. And we're given credentials to log in as that user before we buy the item. Okay, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being recorded in my Burp proxy. Okay, the first thing that I'm going to do is click on my account and log in as the user that we were given. The password was Peter. Hit login. Okay, looks like we have store credit of $100, just like with the previous lab. If we go to home, this is the item that we would like to purchase. And again, the cost of the item is $1,337. So we definitely can't afford it, which means that we need to find a vulnerability in the application that allows us to buy it for $100 or less. To do that, let's look at the requests that the application makes when we add the item to the cart and then try to purchase the item. So if we click Add to Cart, this is the post request that the application is making. Let's send that to Repeater. And then let's view our cart and then attempt to buy the item and send that request to Repeater as well. All right, so if we go to Repeater right over here, let's view the checkout request. So when you click on place order, it makes a request to /cart/checkout. And if we go down over here, it only takes a CSRF token. And so this is not the request that is going to be vulnerable because it doesn't take in client supplied input that could potentially change the price of the item. So my guess is the vulnerability is in the first request when we add an item to the cart. Now, if we go down over here, you could see you've got the product ID, you've got the redirect or REDIR, and then you've got the quantity of the item. We no longer have a price of the item over here in order to be able to change up the price. And so we're going to have to find another vulnerability that is different from lab number 1. Now, if we hit send right over here, and we reload our application, you could see that we've got 2 items in the cart. Now, I'm wondering what happens if I add -1. Does that mean it's going to remove an item from the cart? So let's hit send. Okay, this looks good. So it removed an item from the cart. What if I do -2? Hit send and see if it allows me to have negative items in the cart. And it does. So that is interesting. The total of my item over here is now -1337, so -1337. In some applications that I've tested, if it accepts negative input, what ends up happening is that it sees that the application owes you $1,337, and so it adds to your store credit. So let's see if that's the case for this application. So let's say place order. Over here, it says cart total price cannot be less than 0. So it knows that it shouldn't accept negative values. And so it gives you an error and doesn't allow you to perform that request. So we need to get a little bit creative over here. Let's add the leather jacket again to our application. So if we go 1 over here, hit send, and reload our cart. You could see over here our cart has a leather jacket, and again it costs $1,337. So what I'm going to do is I'm going to go to another item in the application and purchase a negative value of that item so that I could decrease the price of my leather jacket. So let's find an item that costs about, let's say, $100 so that the math is easier for me to do. So this item right over here costs $95.37. So I'm going to click on View Details and I'm going to add it to my cart. Go to Proxy and send that request to Repeater. And let's view our cart right now. So you can see over here, I've added my item that costs $95.37. Now, if we look at that request over here, let's make that item minus 14. Hit send and reload our cart. So I'm adding negative 14 items of this quantity. And here we go. Now, because I added negative 14 and I already had an item in the cart that was there, so it's negative 13, which means it's negative 13 times 95.37. And that gets reduced from the price of the cart, which is 1,337. And so we end up with a total of 97.19, which we can afford because it's less than the store credit. In fact, if we just add one more negative item, we should even decrease the price even more. And it's still bigger than zero. And now we could purchase the item for $1.82. So let's place the order. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. Okay, so before we do that, let's make a list of steps of the items that we need to perform in the script, because there's quite a few requests that we made in the application. So the first one is log in as the regular user. The second one is buying negative 14 items of the item that costed $95. And then we want to buy the jacket itself. And then the cost of the jacket minus all the costs of the item that costs $95.37. It should make my total cost less than the store credit that I have. And so the last step is to submit the request and confirm that we solved the lab. So we have about 4 requests to perform. Let's save that and start writing our script. All right, as usual, we import the libraries that we need. So request library, sys library, URL lib3 library, and then we're going to say from bs4 import beautiful soup, and we'll also import the regex library. Next, we're going to disable and secure request warnings. So disable warnings, URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxy setting. So all HTTP traffic should be sent to where burp is installed. So where burp is running, so 127.0.0.1, port 8080, and then all HTTPS traffic should be sent to the same place, 127.0.0.1, port 8080. And then we create our main method. So we'll say if name is equal to main, then call the main method, and we'll define the main method right over here. So def main, if the length of the command line arguments is not equal to 2, so if the user didn't run it correctly, Then print the usage instructions and example instructions. So print usage %s URL, so the name of the program, which is taken from the command line argument, and then the URL. Similarly, we're going to print the example instructions just so that it's absolutely clear how to run the program. So again, name of the program, and then let's say an example URL, www.example.com. And the name of the program is taken from the command line argument. And we'll exit the program because the user ran it incorrectly. All right, this assumes the user ran it incorrectly. Now let's assume the user did run it correctly. In that case, we create the session object. So s is equal to requests.session. And then URL is equal to sys.argv1. So we take it from the command line argument. And then we're going to call a function called byItem, which takes in the session object and the URL, and then exploits the vulnerability and purchases the item for an unintended price. All right, so that's a custom function that we need to create, and we'll do that right over here. So def byItem takes in the session object and the URL. Now, the first request that we need to perform in that function is logging in as a regular user. So if we go back to our proxy and look at the request that is responsible for logging in, it's this one right over here. So it's a post request to the /login endpoint, and it takes in 3 parameters: the username, which we know, the password, which we know, and then the CSRF token, which we need to extract. And this CSRF token, so if we copy a few characters from it, is taken from the previous request to the /login endpoint. And so we need to be able to extract it from this request so that we could use it in our post request. And that's exactly what we're going to do right over here. So we're going to say retrieve the CSRF token. And to do that, we'll create a variable called login URL, which is just the path to the login endpoint, and that's /login. And then we're going to create a variable called CSRF token. And we're going to extract the CSRF token using a function called getCSRF token that takes in the session object and the login URL. Now, this is a function that we're going to create ourselves, but before we do that, let's say rest of the code over here. Now, I could always implement that functionality right over here, but chances are I'm going to need to call this function multiple times because we have multiple requests. And so I rather have it as a function on its own and then just call the function every time I need it. So let's implement the function s and then login URL. And then from there, we need to perform the request. So s.get URL and set verified to be equal to false and proxies to be equal to proxies so that the request gets sent to burp. And then I'm going to use beautiful soup in order to parse the response. So beautiful soup r.text, which is the response of the request that we just made. And I'm going to set the parser to be html.parser. And then I'm going to extract my CSRF token. So soup.find. And from there, we need to be able to extract the token. So the token over here in the response is in an input element that has a name attribute that is equal to CSRF. And we want to extract the content of the value attribute. And so to do that, we're going to say look for the input element that has the name attribute that is equal to CSRF. And then extract the value that is in the value attribute. And then we're going to return CSRF. All right, so this extracts it and then returns it, and so it ends up getting saved in my variable called CSRF token. Now I have everything that I need to log in as the user. So let's say login as user. And I'm going to print logging in as the user. And so right now, let's go to our post request. Again, it's to the /login endpoint, except in this case, it's a post request. And then if you go down right over here, it takes in 3 parameters, the CSRF token, the username, and the password. And so we need to save these parameters in a variable called data login. And we'll add them right over here. So you've got the CSRF token. We just extracted that and saved it in a variable called CSRF token. And then you've got the username, which we know. And then the password, which we also know. This looks good. Now we can perform the request. So R is equal to s.post because it is a post request. And then it's to the login endpoint. So login URL. Data is equal to data.login, which we just created. And then verify is equal to false because I don't want to verify TLS certificates. And proxies is equal to proxies because I want my request to be sent to Burp. And then what I'm going to do is I'm going to set the response of the request that I just performed to a variable called res. And then I'll check if logout is in the response. So if the string logout is in the response, if it is, that means I've successfully logged in as the user. Otherwise, I'm going to print could not log in as the user. All right, so if we go back to our notes over here, we've logged in as the regular user, so this step is complete. The next step that we need to implement is buying negative 14 items of the item that costed $95. So let's say add item, add negative items over here. So to do that, let's go to repeater and see how that request looked like. So it was this one over here. It was to the endpoint /cart. So we're going to say cart URL is equal to URL plus /cart. And then data cart is equal to the data that was available over here. So product ID, redirect, and then quantity. So let's add that right over here. So the product ID of that item was equal to 5. And then we've got REDIR, that was equal to product. And then the quantity we had set to negative 14. So we're buying it negative 14 times. All right, this looks good. Let's scroll up. Next, I'll perform the request. So R is equal to s.post. And then we'll say cart URL. Data is equal to data cart. Verify is equal to false. And proxies is equal to proxies. All right, so this performs the request of adding the negative item 14 times. So we're done with this step right over here. The next step is to buy the jacket. So let's do that right over here. So let's say add jacket to cart. And the request that was responsible for that is in repeater as well. So I think it was number 5. And again, it was to the /cart endpoint. It was a post request, and it took in these parameters right over here. So let's just copy all this and put it in here. And over here, the product ID was just 1, and then we were just buying 1 item from that jacket. Okay, this looks good. So if we go back to the list of steps, this is complete as well. Now the last item is to check out and purchase the jacket. So let's say checkout over here. Again, it's similar code, so I'm just going to copy this and change up the code a little bit. So it's the checkout URL over here. And the checkout URL was in repeater. So it was this one. So /cart/checkout. And the data was just a CSRF token. So we need to extract that CSRF token. So we're going to add that right over here. CSRF token is equal to get CSRF token, and it takes in the session object, and then the URL is going to be the /cart URL. So cart URL. And then the data in our checkout request is just CSRF. So we remove all of this, and it's equal to CSRF token, which we just set right over here. And then we perform the post request. It takes in the checkout URL. Data is equal to data checkout. Verify is equal to false because I don't want to verify TLS certificates, and then proxies is equal to proxies. All right, so this checks out the item. Now what's left is to check if we solve the lab. And the way we're going to do that is we're going to say if the congratulations string is in r.text, so the response of the request, that means we've successfully exploited the business logic vulnerability. Otherwise, we're going to print could not exploit the vulnerability, and we'll exit the program because it failed. All right, this looks good. Let's save it. And chances are this timed out, and it did. So let's create a new instance of it. And while that loads, let's review our script. All right, so the first thing that we did is create the main method. In the main method, we call a function called byItem. In that function, the first thing that we do is we log in as the user that we were given, and then we add 14 negative items of the item that costed $95, and then we add the jacket to the cart, and then we check out the items that we bought. So if we go over here, chances are this is randomized, which means that the item that costed $95 is probably not item number 5. And so let's look over here. The highest paying item looks like it's $81. So I'm just going to click on View Details and look at the request in Burp. And it's product ID number 20. And so we're going to have to change that right over here. And in this case, I'm going to say -15 because I feel like that would make it under $100, which is our limit. So let's save this. Terminal, new terminal. And then Python 3, business logic flaw 02.py. And then let's copy the URL to the application. All right, my computer crashed, so I had to open this again. Hopefully it'll work right now. So let's paste it, remove the trailing slash, and then hit enter. And we get an error. So it's on line number 12 saying URL is not defined. So if we go right over here, and this should be a login URL. Let's save it. And actually, this should be URL, because it's not always the login URL where we're retrieving the CSRF token. So this should work right now. So let's clear this and run it again and see if there's any errors. And it says it could not exploit the vulnerability. So if we go to Burp and we see over here, it's in item number 20, it's purchasing minus 15 of item number 20. So let's look at our cart right over here. It says the card is empty. Okay, so insufficient funds. So I'm wondering how much was my checkout cost. I wonder if I could render right over here. So it was $119. So what I need to do is increase this value right over here. So let's put it at minus 16. And then our script should work. So let's save it and then clear again and run it. And that's why it's really useful to send all your requests in Burp so that you could debug them if they don't work. And here we go. So you could see over here, it says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of a business logic flaw.